Topic is alert fatigue no more. How found means fixed. Turn security noise into dev velocity. This session will be conducted by Mr. Karthik Rameshkumar, Director, Technical Solutions Engineering, APAC West, GitHub. Let me give a small brief about, sir. Mr. Karthik Rameshkumar is a dynamic technology leader with a career devoted to bridging the gap between businesses and technology. Starting with entrepreneurial ventures, he discovered his passion for empowering the world's developer community, a cause he continues to champion. With a career-spanning roles such as CTO, technical co-founder, DevOps leader, and customer success executive, Mr. Karthik is driven by a steadfast belief. Developers are the backbone of innovation, yet they still deserve greater recognition and support. In his current role as Director of Field Services APAC West at GitHub, Mr. Karthik leads solutions, engineering and cloud solutions across India, South Asia, ASEAN and GCR. He is focused on driving growth, transformation and delivering impact in the age of AI, ensuring developers have the tools and platform to build the future. With this, ladies and gentlemen, let's welcome Mr. Karthik Rameshkumar with a huge round of applause. Let's have the energy back into the room.
Thank you so much. I think I couldn't have asked for a better lead-in than Saurabh. Datadog, like the millions of partners that work with GitHub today, for over 150 million developers that call us home, is the reason why it is. He spoke a lot about agentic DevOps already and giving me a bit of a strong insight into where to start. I serve all of you as GitHub's Director for Field Services and Solutions Engineering for Asia-Pac West. All of you are part of the world's largest developer market, and it is my honor and privilege to be in front of all of you here today. But today I'll start with a story. Once upon a time, when we were trying to set foot on Mars as a human race, the Mars Curiosity rover was this huge project for mankind. NASA tried to get someone on Mars, and the Jet Propulsion Laboratory had actually created this nifty tool called the Curiosity rover, right? Something that would be a first man-made object to ever actually move on Mars. But while the Curiosity rover was on its way from Earth to Mars, somewhere in between, a small problem happened. A bug was discovered, a security vulnerability to be precise, that could crash the software that ran on the Curiosity rover, jeopardizing the mission. The stakes for this couldn't have been higher, right? It's not only about a matter of finance, about $2.5 billion, but it's also the hope of humankind and the ability for us as a human race to be able to scientifically progress forward. It's an important mission and a position to what we want to do. So one nifty tool that came to the rescue then was CodeQL. Because of the way the Curiosity rover's code was written, there was an ability for us to push over-the-air updates. So at some point in time between here and Mars, this open source tool called CodeQL was able to actually send an over-the-air update over satellite communication to the Curiosity rover, and 30 bug variants were found, which was actually one of the reasons why the Mars Curiosity rover landed, carried out its mission successfully, and was instrumental in the progress of the human race as a whole. But what I'm talking about is what you would have already heard in 100 conference talks over and over again. Yes, let's just shift left and do the dance that we always do, right? The ironic reality is, when you tell a developer that we're going to shift left, this is exactly how they end up feeling, right? It's like adding more to a plate that is already full, and I'm already telling you that I don't have gap or time in my place to be able to do more. So what I'm saying is, let's take a step back and let's actually do the breakdown of this problem, right? There's a lot of context switching that developers do. There is a lack of us being able to productively do code. You are not delivering on all the requirements the business is saying, and those keep changing, and you don't feel like you're empowered. It doesn't feel like anybody is hearing you, right? It seems like nobody's listening. But I'm here to tell you that we have, and we figured out that this problem is much like a surgeon that is actually given a butter knife to do surgery on a patient. Imagine, given that choice, would you ever step into a doctor's office or conduct a surgery on yourself if you knew that the surgeon was operating with nothing but a small butter knife? Our focus then shifted on to figuring out one important thing for developers: exploitability. The ability to find out what matters for developers and what exploits could actually be exploited in code with a bad actor. And we wanted to figure out a way so that developers can learn from those over time and get better so that they don't make the same mistakes again when it has to happen. CodeQL, behind the scenes of how it works for all the architecture geeks here, is basically is not a semantic engine. It's fundamentally different from all the other solutions out there and what you see in the market. The way we do it is that we figure out if whatever code you write is converted into a database and a set of queries that then runs across multiple scripts. And then there's a source and a sink that is analyzed to take care of it. But today, what we realize is with all of these shift left tools, it's not only about detecting vulnerabilities and giving you what saying that there's 1,000 vulnerabilities in your code. The fact is with all the code that's being written and organizations growing in scale, there's thousands of vulnerabilities in everybody's code base, and we're struggling to play a game of whack-a-mole with all these vulnerabilities. So that is where we felt and we realized that there is a need for building artificial intelligence and our GitHub Copilot, which is a strong implementation of AI, into an ability to sort of figure out how security and development can come together in one unified plane and take it forward from there. Here, I'll run a small demo for you that one of my team members put together, right? Here in this case is a pull request that you can see. This pull request basically is implementing, let's say, a login functionality in this use case. So here you see there's a bunch of changes that are written, and the way GitHub Advanced Security's CodeQL works is it gives you a prompt in your experience within the pull request itself. You'll be able to see that here you can see the message that GitHub Copilot Autofix also realizes. The screen that shows you the vulnerability has a couple of key features. One, it shows you the ability to look at the source of the vulnerability. Then you can track your way down to the sink of the vulnerability, where it starts and where it ends. So you will actually know the path that said vulnerability transposes through your code base, and it transpires from one function or class to another, and be able to then figure out in which parts of the code base you need to modify and what you need to modify so that you have a full view understanding of the entire life cycle of the vulnerability right through your code base from the start to the end. Also, you will also realize that this Autofix AI generated prompt gives you an insight into what the vulnerability was, how it can be exploited by a bad actor. It shows you lines of code, and in one click, you can commit a suggestion that is offers, and then that code suggestion will be committed as well. So it's a unified experience that starts from detecting a vulnerability, offering you a fix for that vulnerability, and then letting you fix that vulnerability as well. Here's a security overview pane of sort of how it looks like. We realize that security engineers and security teams have to look at this a lot. They have hundreds of thousands of vulnerabilities. In this use case, you can see a huge laundry list of things for a security team to take a look at, right? It's a lot of things to do. We realize the moment we look at it that there's going to be a multiple sprint effort across multiple developers to be able to go ahead and do this. So here, we have brought in security campaigns, which gives you the ability to actually send an auto-fix and create pull requests on set code base as well. Here, you can see a bunch of different vulnerabilities that we have created as well. And once we click on, say, open, you can basically then commit auto-fixes to an entire new branch with all of the vulnerabilities that are across all of these detected vulnerabilities that came across. So this is what powers GitHub Advanced Security's CodeQL, right? It's an open source and free for research engine that you can actually contribute to. So think about this. You have the ability to look at the world security team contributing to your betterment versus just you writing code and finding patterns and security vulnerabilities that fixes your code. So this is what it now translates to. Over the past few years, when we've been using GitHub CodeQL, you can see the world's leaders have already taken it over. In large open source repositories, GitHub Advanced Security is already a mainstay, and it's available for free for use for anyone that's writing open source code. And you'll see that over 2,000 open source queries have been contributed by all of our partners across the ecosystem. So a huge round of applause for everyone that's contributed for CodeQL as well. So in summary, what I'm talking about is it's no longer about finding a vulnerability and then tasking someone at some random point in time to fix it. It's about ensuring that when a vulnerability is found in code, it is already fixed. It is about finding ways to reduce the risk profile for your organization, to enhance your developers so that they are able to write more insightful code over time, and to be able to harmonize your security and dev team so that they don't feel like they're fighting against each other. They feel like they're in this together. That's our clue. But over time, what we've also started realizing is the threat vector across this is not only restricted to queries, right? Here are some examples of articles that I've pulled up from the last 20 years. Every single partner, some of them are our competitors, and all of them are our partners as well, that have put out publications on how you can fix a lot of this stuff by shifts left. All these articles are focusing on a nifty area that I call secret scanning, right? Which is about leaked secrets in your code base as an example. So this is a telling graph that tells you this sad state of despite decades of research, contribution, community team building, that we still haven't cracked the nut on what to do. So if you look at the graph on the top and the down and the below, you basically see security threats are continuing to rise over time. And the graph on the bottom right is basically a graph of how many GitHub personal access tokens we have discovered over a time period. The one correlation in the graph is that it keeps happening, right? And it keeps creating more bugs and more vulnerabilities that we keep introducing into code. As more code is written, therefore more vulnerabilities happen in code. So the reality is that over 39 million secrets were found leaked on GitHub when we did our research in 2024. You can exploit vulnerabilities within minutes. And if you look at the average cost of rectification for a vulnerability, it's close to about $5 million that it takes for an organization. Let's assume that it ran for a bit, and a bad actor was able to access a token, and then they're able to then exploit it. So here are some examples of organizations that have done it. A large car manufacturer had 250 gigs of data stolen because a small nifty secret was leaked. And in a large ride-sharing platform, about $148 million settlement was reached just because a leaked code was found with a secret token that actually was there in the code. So here's the way I think about it, right? I feel like any secret that is found in your code base is a way for you to give the keys to your kingdom, right? It gives a bad actor immediate access to resources that are supposed to be used by your organization. There are tons of automated bots and AI bots that continue to scan publicly available code in repositories that are able to then exploit that vulnerability and use it for their own advantage. The worst could be like a Bitcoin mining bot or something like that. And you have multiple committers working across a lot of repositories and a huge team, usually in enterprise scale, that is contributing. So there's a lot of sprawl, and you have very little insight into what's going on and where it's going on. Detection is important, but it's not the make all, break all of secret scanning, right? You could have a bit of a timing gap, there could be false positives, and the fact that even today, despite the importance of security teams that we have, there is still about one security engineer for every developer out there, for every 100 developers out there. So think about that ratio, right? We still don't have enough security engineers to be able to realistically do it. So all these engineers are spending countless hours in triaging, validating, finding vulnerabilities, and this becomes a huge job for them. So the best way to defend ourselves is to prevent an attack of that nature from happening. And the hidden cost of the 5 million that I spoke to you about actually starts incrementally scaling over time. So if you find and detect it in a few hours, it's very low cost because there wouldn't have been much exploit to a token, for example, like an AWS token that got leaked, right? But let's assume that it happens over multiple months of time, then the cost keeps building up because your bad actor has a lot of time to be able to then exploit the resources for the needs that they want to gain. So the power of proactive secret management basically gives you a couple of features, right? One, you are able to reduce your attack surface. You improve your developer velocity by giving them something that is in their flow when they're writing code, giving them the capability to then prevent secrets from happening. And obviously, you protect your brand's reputation, which is a very important piece. That's why we're introducing GitHub Secret Protection, which is a way for you to use push protection to be able to comprehensively cover your code base across multiple surfaces, and I'll talk about that a little bit later, with a lot of detection accuracy. And we have actually seen that over 1,700 secrets, for example, an organization with 2,500 repositories was found instantly when they enabled secret scanning. So this is what push protection gives to you, right? So one is that when a developer is writing code, there's a lot of ways for you to actually find said vulnerability, and a lot of tools in the market do it, where they actually scan the code after the code has been pushed and the code already lives. The problem with that is once the code is pushed, the code is already available for anyone, even within your organization or outside, to be able to access. The intention is the code should not even be pushed before you're able to do it. So you should be able to have an ability to not have to configure it a lot. You should be able to avoid remediation and prevent it at the very early on and do it from there. So here I'll go through a small demo to showcase how push protection works. So here's a TypeScript file in this use case example. We've actually taken a token, which is actually GitHub personal access token in this file. So to show you how push protection works, I'm going to try to commit these changes when a GitHub personal access token is already in there. So when I try to commit, what you'll basically see is GitHub comes up and gives you a prompt that basically says, boss, you cannot commit this. There's a secret in this. And because of this is happening. So what you should be doing, what actions exist. And because sometimes there could be a false positive, you have the ability to also flag that so that your security team can then review it. So it gives a lot of power and capability for developers. And this is across all surfaces, from CLI to your IDE to you writing code in Git, in the GitHub desktop app and all of those. So this is where it comes. So beyond code is where we help you. So you are not only writing code in one space, there's also collaborative spaces, for example, like issues and discussions. You are writing code in documentations and wikis. If your developer writes any tokens or secret across any of these use cases, including public gist, a lot of us use public gist for sharing small snippets, for example, you will be able to figure out these secrets if they originate from your enterprise, and that's where we start from there. So our detection accuracy is actually powered by a very unique engine, and I'll talk a little bit about that in the next slide. We have over 150 service providers that actually partner with us to validate this. Remember what I spoke to you about when I started off, and I told you that our focus is on exploitability, right? So exploitability continues to be here. There's no point in finding a random secret that is not exploitable, that just follows a sort of a string pattern match. It's about finding an exploit that is, or a secret that actually is valid at that point in time, right? A lot of detection engines actually have a high false positive rate. Ours has a very low one, and we have infused artificial intelligence so that you can also look for it for generic passwords and come up with types where you can figure out how to sort of fix that much better. We prioritize your remediation by actually giving you the ability to validate your checks and then have the ability to also dismiss alerts based on priority that you have. And we are built for enterprise scale from the ground up. That's the one unique thing that you'll see with everything with GitHub Enterprise, right? It's a couple of button clicks to set up, very, very simple to scale, but at the same time, it offers you all the enterprise-grade controls that you need so that you can granularly figure out what works for your organization and what does not. Our secret scanning partner program, and if you have a SaaS application or you work based on secrets or tokens, we highly encourage you to join a secret scanning partner program, because obviously we're the home for over 150 million developers. So we welcome you to be a partner. Is that we actually have a validity to actually validate if a said secrets is actually valid. So we hit our partner's endpoint, we check and validate whether or not the secret is valid and take it back from there. So if any of you have applications or APIs, Datadog is a fabulous example of a partner of ours, as Saurabh would already, you've seen Saurabh on stage right before me, you are able to then look at a token and then figure out if the token is valid or not and then take it forward from there. So this helps prevent false positives and helps enhance developer experience much better, because again, your developers are not looking at a secret that is actually not exposed. So this is the secret scanning promise that GitHub offers. It's a prevention-first approach. It's streamlined for remediation. It enhances developers and their productivity. And at the end of the day, this brings together much better brand protection. So the story that I love telling when I come outside is of a much-loved brand that all of us very well know of, is the Carlsberg Group. The very interesting thing is that when they immediately enabled secret scanning on their repositories, and they had already used GitHub Enterprise in the past, the moment they enabled secret scanning, they were able to actually see over 600 unknown secrets were there in their code base. Instantly, within one click of a button, we're able to figure out all those secrets. So think about it, right? You can go from unsecure to building your security posture into a mature manner with a couple of clicks and enablement. We've heard feedback from our customers though. A lot of you that already use GitHub Enterprise will know that in the past, GitHub Advanced Security, which was the package that offered both of these SKUs together, was coming as a bundle SKU. You basically had to buy secret protection and you had to buy CodeQL in one bundled purchase. We've heard your feedback and feedback from customers like Carlsberg to then break it down into two separate SKUs that are now available for you to purchase, both off of GitHub as well as if you are already on the Azure Marketplace. We offer secret protection with all the features that I said as a separate SKU, and code security is offered as a separate SKU. So the key takeaway that I would tell for all of you that's here with me today is, if you already have GitHub Enterprise or are trying to take a trial of GitHub Enterprise, please go ahead and take it. And please try to take our secret risk assessment that's actually available as a tool for you to use now. It's a single button click, a couple of configuration changes, and for free, you can actually look at the security posture in your organization when it comes to secrets. You'll have a clear list of all vulnerabilities that exist and sort of figure out what works and what doesn't work for you. I think together we can build the story of developer experience for all of the enterprise's developers, and I look forward to having conversations with you if you have any questions further. But thank you so much, GainSkills, for the time, and I look forward to catching up with you guys. Thank you.
Thank you so much. Everyone, please give a huge round of applause. Sir, can you join us just for 30 seconds? May I invite Mr. Saurabh Girdhar, CTO, Carefy. Sir, please join in to present a small token of appreciation to Mr. Karthik for joining in here today.